Right, good morning. Your I can statement for today is I can add fractions with unlike denominators. Um, so far not this week, but in the past math lessons or last week, we've been working on finding common denominators and estimating sums and differences. And today we're going to actually take two fractions and add them together with unlike denominators. Your other I can statement is I can make sense of the problem and push through the problem when it gets tough. So we're working on perseverance today as well. Your sample problem for today is over the weekend, Eleni ate 1/4 box of cereal and Freddie ate 3/8 of the same box of cereal. What portion of the box of cereal did they eat in all? So I'm going to use my cubing strategy first as always. I'm going to circle the key numbers, which is 1/4 and 3/8. I'm going to underline my question. What portion of the box of cereal did they eat in all? I'm going to box any keywords, and I would say in all is probably the only keyword that's super important. I'm going to eliminate anything that I don't need. I don't need to know that they ate the box of cereal over the weekend. And then I'm going to solve. So the question is asking what portion of the box of cereal did they eat in all? Well, in all tells me that I need to add because I'm putting two different numbers together to give me a total of what they ate all together or what they ate in all. So I know that I'm going to have to add. I have two options to solve this problem. The first option is to use fraction strips, and you will have a PDF copy and a paper copy of fraction strips to use if this is how you choose to solve the problem. So what I did was take my PDF version of these fraction strips and just put them right onto a notebook file, but you can use them on paper if that's easier for you. So this fraction strip, this yellow part, represents the whole box of cereal, or one whole. The purple fraction strip represents 1/4, and we know that Eleni ate 1/4 of the box of cereal over the weekend, and this represents her portion. Freddie ate 3/8, and I have 1/8, 2/8, and 3/8 right here. And this green strip represents his portion of the cereal box that he ate. So now my question is, how much did they eat in all? How much did Eleni and Freddie eat total? So I have to take the purple strip and the green strip and combine them together to get a total amount. So what I can do by looking at these fraction strips is say, okay, well, I see that there's 1/8, 2/8, and 3/8 down at the bottom. But I also am noticing that 1/4 right here is equal to 2/8. Because if I were to cut this in half of 1/4 is equal to 1/8. As you can see right here, it's the same size as these 1/8 strips. So I can see that 1/4 is equal to 2/8. So I'm going to change this, since I broke it up, I'm going to change this to say 1/8 because I split it in half, and change this to say 1/8. And now I can count up how many eighths I have in total to show me how much they ate in all. And that's 1/8, 2/8, 3/8, 4/8, 5/8. So they ate 5/8 of the cereal box total. 5/8 of the cereal box because Freddie ate 3/8 and Eleni ate 1/4, which we also saw was equal to 2/8, and 5 or 3 plus 2 gives us 5/8. So that's option 1 using fraction strips, and these are pretty clear cut. They're easy to see. I'm able to see what things are equal to what. So that's one way to do it. Your second way is using or finding a common denominator like we've been doing. So what can you do to make 1/4 and 3/8 have the same denominator or the number in the bottom? So I just set up an equation here. I said 1/4 plus 3/8 equals question mark. Well, question mark is going to be the total that they ate together. 1/4 represents what Eleni ate, and 3/8 represents what Freddie ate. So now I have to say, okay, I need to add these two numbers together to find the total that they ate. Well, I can't add a fraction with different denominators, so I have to find a common denominator amongst these two. So the first thing that I need to do is look at my denominator and say, okay, well, is there anything that these two numbers, 4 and 8, have in common? Well, if I know my facts, I know that 4 right here is half of 8. So maybe I can leave 3/8 by itself and leave that as my common denominator and turn 1/4 into something else to make it have an 1/8 on the bottom. So 4 times what would give me 8 on the bottom? If you said 2, you are correct. 4 times 2 over 2 would give me 8 on the bottom. So 2 times 1 is 2. 4 times 2 is 8. And now I have a new fraction that I can add together. So I have 2/8 plus 3/8 gives me 5/8. And you'll notice that when I'm adding fractions with common denominators, I only add the top numbers. My bottom number or my denominator stays the same, and I add my numerator or my top number. So that's where this 5 is coming from, and that's why this 8 is staying the same, because we only add the numerator. So 3 plus 2 or 2 plus 3 gives me 5. Leave my denominator the same, 5/8. So you can use either of these methods when you're solving. You can use your fraction strips to model it, or you can simply find a common denominator and add your numerators to get your final answer.